Good morning all. In this lecture video, we are going to discuss the concept of divide and conquer. Under this algorithm design technique, we are going to discuss how to sort the numbers using merge sort. So first let me explain what is the concept of divide and conquer. So it's a very well known algorithm design technique. First it will divide the main problem into one or more subproblems of same size. That is the meaning of divide. Okay, then second is conquer. So you have to solve all the smaller instances recursively. That is, the subproblem has to be solved independently. Then you have to combine the solutions of all the subproblems together. Then we'll get the solution to the main problem. That is divide and conquer. What is the difference between divide and conquer and the decrease and conquer is, we can say the example is the binary search. The binary search is not fully based on the concept of divide and conquer. It is a decrease and conquer because we are searching only one half of the array, not the entire array. So that means we are not solving both the subproblems. Even though we divided the array into two halves, left side half of the array and the right side half of the array, the search process is carried out depends on the search key, either in the left side half of the array or at the right side half of the array. So the binary search is not comes under the divide and conquer. It is decrease and conquer. So this is the concept of the divide and conquer shown in a pictorial way. So a problem of size n, it will be divided into one or more subproblem. Here for the simplicity, we have divided into two subproblem of size n by 2. That is, we can divide it in the factor of 2 or factor of 3 or whatever it may be. So, but of equal size. If you are dividing the first subproblem is n by 2, again the second problem is also should be divided by n by 2. Then the subproblem 1 will be solved independently. Then the subproblem 2 is also solved independently. Then if you combine the solutions of all these subproblems together, you will get the solution for this main problem. Here the subproblems are implemented as a recursive routine. Okay, again, what is the logic when you are applying for this main problem? The same logic has to be applied for the subproblem 1 and as well subproblem 2. So there are many examples which can be solved under this divide and conquer. The most famous example is the sorting. Okay, under the sorting, the quick sort and the merge sort is solved under the algorithm design technique divide and conquer. And the binary tree traversal, multiplication of large integers, Streisand's matrix multiplication, closest pair and convex hull problems, and binary search. That's I told decrease by half. Okay. So in among these examples, in this video, we are going to discuss about the how we are going to sort the numbers using merge sort by applying the concept of divide and conquer. Okay. Before getting into that problem, I told the subproblems are solved by writing a recursive routine. When you how to analyze the efficiency of those problems, we have to frame a recurrence equation. Then we are supposed to solve the recurrence equation. So the general divide and conquer recurrence is of the form a into t of n by b plus f of n. So where a is nothing but how many instances of the subproblem you are dividing, whether it is a 2 or 3 or 4. Where b is nothing but the factor, okay, whether you are dividing by 2 or 3 or 4 and so on. Where f of n is nothing but the time taken to divide the subproblem and as well as the combining the solution to the subproblems is nothing but f of n. So the general divide and conquer recurrence is of the form a into t of n by b plus f of n. So these kind of recurrence can be solved by applying the master theorem. We can also solve by using the substitution method, but we can easily solve by applying the master theorem. What is the master theorem says that if f of n is belongs to theta of n to the power d, where d greater than or equal to 0, if a is less than b to the power d, then we can say that the efficiency of that algorithm is theta of n to the power d. So from this, if f of n is belongs to theta of n to the power d, okay, where d is greater than 0, the master theorem 1 says if a is less than b to the power d, the time complexity of that algorithm is theta of n to the power d. If a equal to b to the power d, then t of n is equal to, otherwise t of n belongs to theta of n to the power d log n. Okay. If a is greater than b to the power d, t of n belongs to theta of n to the power log a to the base b. The same thing can be holds for big O and as well as this omega notation. So for example, if you take this function, t of n is equal to 4 into t of n by 2 plus n. So t of n belongs to what is that? So we can say that here in this example, a equal to 4. So because the problem will be divided into 4 instances. The factor, that is b equal to 2. So f of n is n. So where f of n belongs to theta of n to the power d, we have to take it in the form of. So here we have this linear, so that the d value should be greater than or equal to 0. No, since it is f of n is linear, here the d equal to 1. The value of d is 1. Okay, so then you find out whether a is less than b to the power d, or a is equal, or a is greater than b to the power d. Okay, so obviously you can say that a is greater than b to the power d, that is 4 is greater than 2. Okay, so the time complexity belongs to theta of n to the power log a to the base b. So that is log 4 to the base 2. That is going to be the time complexity of this. Okay, then consider this example. The value of a equal to 4, b is 2, then here the d equal to 2. Okay, so both are equal, so that the time complexity is theta n to the power d. So what is the value of d here? 2. So n square log n. Likewise, you can apply the master theorem, then you can easily solve this general divide and conquer recurrence. So now we are going to discuss about this merge sort. For example, this is the array we are going to solve using this merge sort. So it will contain some 8 elements. Okay. What is the concept of the merge sort in the sense? First thing you have to divide. Okay, that is merge sort. Then you have to apply the second phase is merging. Okay. So you divide this main problem into 2 subproblems of equal size. Okay, since it is n is equal to 8, the first 4 elements will come into the one array, the second 4 elements will come into the second half of the array. Okay, again this is the subproblem 1, this is the subproblem 2. Okay, again you divide the subproblem into 2 subproblems of equal size. So 8 and 3 will be in one array, 2 and 9 will be in another. Same way this you will be divided into 2 subproblems. Again you divide this. Okay, so the division goes until you have single element in this. So now all these are single element sorted array. Okay, the second phase of the merge sort is you have to combine, that is merging. Okay, so what is the concept of this merging is, you have to take the 2 sorted array. Okay, and then you have to compare the elements in the first position of the first array with the first position element in the second array. Whichever is less, you move that element to the resultant array. Then you increment that pointer alone. Okay, next you compare the next 2 elements. Whichever is less, you move on to this resultant array. So likewise the process will go on. If either one of the arrays vanish first, you move the remaining elements in the another array directly to the resultant array, since all the elements are already in sorted order. Okay, so when you divide this into one single sorted array element, this second phase merging will goes no. So you compare 8 and 3, which is smaller 3, next 8. So these 2 sorted arrays will be merged into one single array. Again these 2 sorted array will be merged into one sorted array 2, 9. Again 1, 7, 4, 5. Okay, second again you have to combine these 2 sorted array. You compare 3 and 2, whichever is less 2, that is moved. Next you compare 3 with 9, which less 3. Next you compare 8 and 9, 8 is less, it moved here. So here there are no more elements in this array. You copy the remaining elements directly to the resultant array. Again these 2 subarrays will be merged. 1, 4, 5, 7. Again these 2 subarrays will be merged. Obviously when you are applying the merge, both the arrays should be in sorted order. Okay. So then we'll get that all the elements are in the sorted order. So the first phase is split. A is an input array. It should be sorted by using the merge sort. First step is you split the array into two about equal halves and make copies of each half in arrays B and C. You divide that input array A into two halves, store it in one array B and C, sort the arrays B and C recursively. So finally you have to merge the sorted arrays B and C into one array, input array A. So you have to repeat the steps, that is compare the first elements in the remaining unprocessed portions of the array. Copy the smaller of the two into A while incrementing the index indicating the unprocessed portion of that array. Once all the elements in one of the arrays are processed, copy the remaining unprocessed elements from the other array into the resultant array. This is the concept of merging. So this is what the pseudocode of the merge sort. So it will take the input array of 0 to n minus 1. So if n greater than 1, so that is you have to divide this input array into two halves equal size until it will have only one element. So first you divide the input array A 0 to n by 2 minus 1. That is first half of the input array is moved to B. Then the remaining second half of the input array is moved to C. Okay. Then you are calling the procedure recursively, merge sort of B of 0 to n by 2 minus 1. Again merge sort of 0 to n by 2 minus 1. Okay. So this process will be called recursively until if you have the value greater than 1, that is each elements in the input array will be divided into 1 like that. Okay. So the next you have to apply merge. Okay, so which means that the arrays will be available in B and C. So these two sorted arrays will be combined and you are moving into the resultant array A. So this is the pseudocode of the merge. Okay, so B is a one sorted array, C is an another sorted array. You have to move all these elements from B and C by combining into the resultant array 0. So where the number of elements in the array B is P, the number of elements in the array C is Q. Okay. Obviously the number of elements in this input array is P plus Q minus 1, which is going to be in sorted order after applying this merge. Okay. So we'll set the index for this array B I equal to 0. Then we'll set the index pointer j equal to 0 for moving the elements into the array C, k equal to 0 for the index pointer input array A. Okay. So what we have to do in the concept of merge, you have to compare the elements, okay, which is pointed by the both the pointer, whichever is less you are moving into the resultant array. So this process has to be repeated until either one of the array is going to be vanished. So while I less than P and j less than Q, which means that still you have some of the elements in the array B and as well as array C. Okay, then you are comparing if B of I is less than or equal to C of j. You compare the element in the B array with the element in the C. Whichever is less, you move that element into the resultant array. If B is less means you move B of I to A of k, then you increment that pointer LO, I equal to I plus 1. Suppose if the element which is present in the C array is less, then you are moving C of j to A of k, you move that pointer j equal to j plus 1. Okay, irrespective of whether we are moving element of an array B or element of an array C, okay, you have to increment k equal to k plus 1, which is a pointer for the resultant array. Okay, so this process has to be repeated until either one of the array is going to be vanished. Okay, so if either one of the array is vanished, it will come out of the while loop. Again, you have to check which array is having an remaining elements. If I is equal to P means, which means that you have processed all the elements in the subarray B. Okay, so you have to copy the remaining elements in the array C directly to the resultant array. So that's why copy C of j to Q minus 1 to A of k to P plus Q minus 1. If not, which means that array B is having some elements and the subarray C is not having, that is it is vanished. If so, you copy the remaining elements from array B directly to the resultant array. Finally, which is going to return this resultant array. So when coming to the analysis of this merge sort, here the basic operation is the comparison. So we have to form the recurrence now. So we'll go for this comparison is C. So we frame that C of n is equal to here 2 into C of n by 2 plus C dash of n. So which is equal to 2 into C of n by 2 plus n minus 1. I'll tell you what is that. So you know that the general recurrence is A into T of n by B plus F of n. So here A is 2, since we are dividing that main problem into only two sub problems. So that's why A equal to 2. And again we are dividing that problem into equal halves. That is factor of 2. So A equal to 2 and B is equal to 2. What is this f of n? So the f of n is nothing but I have already told. It is the time taken to merge the solutions and as well as divide. Since here the number of the basic operation is the comparisons. So in the worst case, while you are merging, you have to compare at least n minus 1 comparisons. Since all those in both are in the sorted order, okay, so you have to compare, then only you can move the smaller element into one resultant array. So at the worst case, it will do n minus 1 comparisons. So where f of n or c dash of n is equal to n minus 1. So how we are going to solve actually by applying the master theorem. So once again I'll repeat. Okay. This is what the master theorem we have already discussed. Okay. So this all cases have the same efficiency theta of n into log n. So because A is equal to 2 and B is also 2. Okay, so where f of n is equal to n minus 1, so that the value of D equal to 1. So A is equal to B to the power D. So obviously the time complexity belongs to theta of n into log n. So this is the worst case efficiency of the merge sort, and as well as the best case and as well as average case. All the cases the efficiency is theta of n into log n. Thank you.